My name is Adam Bar, and I would like to continue the topic that was started this morning by Tomasz and Patrick about the performance in the web. Let's start with this guy. Who knows what's his name? One, two. Oh, OK. So what's his name? Mark. Yeah. He is known in the web world for the one sentence he said back in 2012, that relying on the web platform back then was one of their biggest mistakes as Facebook as a company. They should have relied on native technologies instead. It was when we had no progressive web apps in the web. We had no push notifications. We even had no camera access APIs available. But one thing, what bothers them most was very simple. It was performance. They have found a lot of problems with having their web app being smooth, and they have no way to work around it. So they left the web platform, leaving the message that the web is just too slow for that kind of usage. And we still hear the echo of this message even today. Before we go, let me clarify one thing in the title of this topic. I have a mobile world back then, but let's look at the statistics that are quite clear that at the moment the traffic from the mobile devices actually surpassed the traffic from the desktop devices. And right now in Poland it's more than 60%. So we can probably cross out the mobile word from this title and it will still be relevant. We just need to shift our mindset from that kind of environments we are used to as developers, as Tomasz said this morning, to more something like this that resembles our real user better. It's a middle-class smartphone from 2015 or something like this. And it means that we need to test our applications on that kind of devices. Otherwise, we are probably missing what the real experience for our user is. And we might be missing the real bottlenecks in the performance of our applications. And we are producing the applications that are slow by default. So that is true. It cannot compete with native development in terms of performance, for sure. Coming back to the title of this talk once again, what that Holy Grail actually is. It was, in medieval mythology, something that everyone wanted to find, but no one actually knew how to find it. So I believe mobile web performance is something similar. We all heard about the statistics that having a website that loads quickly is best for our conversion rates. And the opposite, that if our website failed to load quickly enough, our bounce rate goes up. So being in that sweet spot over here should be our grail, should be something we should look for. But what is the path to our grail? There are actually many paths, and we need to we can take any of them or all of them. Performance starts at the backend. If our backend is slow, we can have a lot of problems fixing it in the front end. Then there's a network. Networking might add a big overhead because of latencies and all the stuff related. Then content reaches the browser when it needs to be processed. It needs to be rendered, and all the scripts need to be executed. When this is done, we have a runtime that when we have animations, we have user interactions, it all needs to be smooth and not pause the user for any reason. And performance is even in UX. There are some patterns that actually might hide our performance problems or might make it more prominent. So there are many paths. We are not going to talk about the server side today, and we are not going to talk about the UX. We will focus on the three things in the middle that interests front-end developers, like most of us probably here are. So there are three parts: network, load and render, and runtime. But Patrick already covered most of the runtime part, so we will actually focus on that too, on the network and load and render. As we go, I would like to share my story about the website I am running, what web could do today. Anyone already heard about it? Yeah, that is nice. It is about the APIs available on the web platform to integrate with the hardware, especially with the hardware on our devices and with the mobile operating system. So I recommend you to check it out later. All the links will be at the end, and the slides are available, so don't bother checking it right now. I am maintaining this project this website as a side project in the evenings after my kids go to sleep, so I don't have much time to invest. And initially, I just did whatever was the simplest and whatever was the obvious for me. So the result was that it took 7 seconds to load this website on a real mobile device on a simulated slow 3G network. FP is first paint, so before the first paint, nothing is actually shown to the user. There's a blank screen only. And it took almost 10 seconds for first meaningful paint. FMP is first meaningful paint, so the first moment the user actually sees something that makes sense for them. So in my case, these are those labels of features. So definitely there was a room for improvement. And as I go, I would like to show you what I did and what were my results in terms of loading time. Let's start with the first part about networking. HTTP2. Who is using HTTP2 in their projects? Well, not much, but this is consistent with statistics because only 16% of websites are using HTTP2 at the moment. And this is bad because just by enabling the newer version of the protocol, we are able to have some performance gains because of the header compression and especially because of the better connections handling via multiplexing. Now let's look at the demo that is showing a difference, possible difference between HTTP2, HTTP 1.1 and HTTP 2. Both pictures are loaded from the small pieces. Each piece is loaded in a separate HTTP request from the same server. The left one was loaded using HTTP 1, and the right one was loaded using HTTP 2. Here the difference was like 5 times, so it was magnificent. In my case, my website is not a jigsaw puzzle, so the result was not that impressive. But still, just by enabling the newer protocol, I was able to reduce the loading time by 3%. So it was quite easy for me, so really, why not? And with HTTP2, there comes potential of another optimization within server push feature. So when our server is push aware, and the browser of our client is push aware, whenever the client asks for some content, for example, index.html, the browser might respond not only with the content requested, but also with the content that the server knows the browser will probably ask very soon. So for example, styles, sheets, or JavaScripts for the website. So when the user actually asks for that content, the user might already have it cached in the browser. It is unfortunately a bit complex at the server side, and not all the browsers implement it consistently, so we might look for simpler alternatives. We fortunately have some in form of preload and prefetch. Preload is a very simple thing, a link element that we can add to our head section in HTML, and we are instructing the browser to download a resource as soon as possible, even before it is actually used by our website. This is especially useful for web fonts that are normally only discovered quite late in the process of page loads, only after the CSS, when it is defined, was being parsed. So we should try to have it as soon as possible with preload. Prefetch is very similar. It's also a link element that we can add to head section. It is useful in case we have kind of a stepped process or kind of wizard, and we can guess where the user will navigate next. So by adding the next page URL to the prefetch link, we are asking the browser to actually have the resources already available in the local cache. So when the user opens it, it is just the rendering that's left. I added preload to my website for both the fonts I am using. One font is for icons, the second is for text. And just by adding 2 lines of HTML, I was able to reduce the loading time by 1.5 seconds. So it was really impressive given that it was 2 lines of code. My first paint actually increased a bit, but it's the first meaningful paint that actually matters for users, right? There are other prefetch techniques available in some circumstances. DNS prefetch makes sense if we are interacting with another domain, so we can ask the browser to resolve the DNS address upfront before it is actually needed. We can even ask for establishing a TCP connection upfront before it is needed. Or in some cases, in some browsers, we might ask for pre-rendering. It's a very powerful thing that actually runs a kind of a hidden tab of the browser when the next website we assume the user will visit is fully downloaded and rendered in that hidden tab, and when the user tries to open it, it is just swapped into a view. So it's kind of immediate for the user in case of pre-rendering. What's more, content delivery networks, CDNs, are still a crucial thing for networking performance, because this is how the typical breakdown of our front-end application timing looks like. So it's not the content download that actually takes the most time, but it's waiting. It's time to first byte, TTFB. It consists of the server-side processing time, but in most cases, in the front-end heavy application, this is only serving a static JS or CSS file, so it should not matter that. What's here in that green part, actually, is the networking, mostly. So all the DNS time, all the handshakes for certificates, and routing time. What content delivery networks offers us is to cache our resources as close to the user as possible so that routing time can be reduced. So if we happen to have a distributed user base or we have hosting in the States, it might be very beneficial for us to use content delivery networks. It might reduce the networking time by an order of magnitude. And there are other really simple techniques that are known for ages and are still very, very important for performance, for subsequent visits. We should always remember about HTTP caching. All our immutable content should always be served with long expiration dates so that in a subsequent visit, the user is not even reaching for the network for that content. And all the mutable content should be served with cache control no cache header, which literally doesn't mean not to cache, but it means that the browser will actually cache the content, but in the subsequent visit, it will ask the server if the content that is cached is still fine to be used. So we can shave some milliseconds on the transfer time. We can go even further right now with service workers that are allowing us to upfront cache all the resources needed for the app to even work offline. So if our service worker is serving all the needed resources with cache-first approach, we might eliminate the need to go to the network at all in the subsequent visit. Okay, I used both of these techniques. So these statistics will obviously only make sense for a subsequent visit because we have no cache or no service worker in the first visit. But still, it is very important for our loyal users, for sure. So with HTTP cache, the loading time was reduced to less than 3 seconds. And with service worker, that reduced the networking to only a single request. It was less than a second. So definitely good thing to have for our loyal users. But it doesn't mean we can stop here because our first-time visitors are probably also the ones we should care about. And what we can do with them? We can handle it in the load and render part, which mostly boils down to the critical rendering path. So the order in which the browser processes all the resources and that the browser downloads, and all the processes that needed to be run in the browser in order to display a complete website. So in most cases, it is drawn in that kind of waterfall chart. You might be familiar with that from Chrome DevTools, for example, or from webpagetest.org, a website that is pretty well known to check the performance of our front-end applications. So let's think about the processes that are running in the browser when the website is being displayed. First, rendering. So the process of putting stuff on the screen. And we might think, when can it happen? Is there something that might stop it, or should it be running all the time the content is being downloaded? Well, it can't. It can only be run up until style sheet is discovered. When there's a CSS in HTML, the rendering needs to stop. It is blocked until the CSS is parsed. So observation number 1, CSS blocks rendering. Why is that? It is because the browser are trying to avoid flickering on the screen, so when it is obvious that the layout will change, the browser just stops and waits until it knows what should be actually rendered. It's kind of obvious. Let's think when scripts can be executed in that process. Can it be executed here exactly after it is available? Nope. In this case, it needs to wait for CSS to be processed too. Observation number 2, CSS blocks script execution. So it means CSS is kind of important in our critical rendering path. Yes, it is. Why is that? Because that might be a bit surprising. It is because the JavaScript might ask the DOM what is the computed styles, or what are the computed styles for a given element, and the browser needs to respond deterministically. So it needs to have that CSS processed. OK, let's go one level deeper, the most basic process that runs in our browser, and this is parsing. So the process of translating the incoming HTML stream into the DOM tree. So it is kind of basic. It sounds like something that should work no matter what. So can it run all the time? Obviously, no. It needs to be stopped when the JavaScript is encountered. So the first script element in our HTML stops parsing. There is no parsing at all running up until far on the right on that chart, after that JavaScript was not only downloaded, but when it was actually executed. So observation number 3, JavaScript download blocks parsing. And why is that? It is because we have legacy APIs available in the browsers, like document.write, that are intended to modify the DOM tree being built exactly in place and in time it was encountered. So the browser cannot know if we are actually going to shoot in our foot or not. So it allows us to do that and waits to see what we are going to do in our JavaScripts. That doesn't sound nice, right? So we might look for how to work around it. And there's an easy way. We can mark our script as asynchronous, effectively telling the renderer it can run, because we are not going to shoot in our foot. And then the parsing can continue during the script download part. It is very simple. It is just an async attribute that we can add to the script tag. And that's basically all. But we still have a hole here. That hole in parsing is because of the script execution. So observation number 4, JavaScript execution blocks parsing. This is because it's generally how JavaScript works. It needs a main thread in most cases to execute, and this happens to be the same thread that is used for parsing. So they just need to share. Is there something we can do about it? Yes, we can mark it as deferred. We can mark our script as something that is not that important to be run as soon as possible, and we are fine to wait until the parsing is finished. So it will still be blocking, but it will not actually block anything for our user. So the user will not be affected by the deferred script. So for example, all our social widgets, ads, and stuff like this should never block our parsing. Again, it's only a simple defer attribute that we can add to the script element. Now I will show you a demo of a single website being loaded in 2 different modes. I have borrowed these videos from Google I/O talk about performance metrics from this year. And let's spot the obvious difference between them. The right one was a bit faster. The left one, in turn, started with a header and a loading indicator. And how do you think? Which of these 2 versions people tend to like more? The left one, even though the right one was a bit faster to render. Because obviously they can see something from the start and they have an impression that the website is very busy working for them. And on the right side, it looks like the website is broken until it's done. So we should always try to have that left side experience for our users. How can we do that? We should ensure that the CSS needed to render the topmost part, so that might be just a header and a loading indicator, is not being delivered late in the process, but it will be best if it's inlined directly in the style element in our head section, so that no resource is being blocked. Everything can be rendered as soon as possible. So we then need to ensure nothing blocking is actually served, like any more CSS that will stop our rendering, nor any JavaScript that will stop parsing. So everything needed to render the top part needs to go before these blocking resources, and all the rest needs to go down. So we should dynamically load all the rest after that main part is actually visible. So that might not be simple in case of complex existing applications, but it's definitely something we should think about it. But it's not the whole story. We already had a picture of a big animal about that this morning. So it's about size. The average size of our websites in 2017 is more than 3 megabytes. So the sum of the length of the content needed to render a single view of a website. We definitely have a website obesity crisis. This is also a title of a great talk by Maciej Cegłowski. I really recommend you to watch it later. It's an eye-opener in this topic. There's also a great website that was called Cost of Modules. Right now is called Bundlophobia or something, but the address is still valid. And that shows what is the impact of adding NPM package to our front-end bundle. So for example, just by adding full Lodash package, we are adding half a second to our download over 3G time. Half a second. For jQuery, it is 0.6. And for React DOM, which is a bigger part of React, it's 3/4 of a second. So I'm not saying that there is no place for frameworks or libraries, but we should always remember nothing comes for free, and every kilobyte that we are serving to the users matters. Especially that in case of JavaScript, it's not only the download time that matters. It's also time to parse it, compile it, and execute it. And that might sound like something that our browsers are doing really fast at the moment. But for example, React on iPhone 5S, that yellow part takes more than 100 milliseconds. So for bigger libraries or for worse devices, it's a really big problem. I had the same problem on what web can do today. I used the tool that Tomasz already mentioned, the coverage tool, and it turned out that I am serving Bootstrap, but I'm using only 5% of it, and I am not using half of my JavaScript. So definitely I had a problem. There is a page that calculates how much the user pays in terms of money in their data plans for that content I am serving. So it's kind of rude for to ask our users for paying for useless data. What can we do? We can tree shake, also mentioned by Tomasz. We can code split. We should now, especially on HTTP2, we should no longer push the big giant bundle to the user. We might even go to the very granular level and serve only the things that are actually needed for a given view. But nothing is more important than the third point. We should apply critical thinking and common sense to everything we are using. I did that. I've spent 2 evenings trying to figure out what is the code I am not using and removing it. And I was able to remove 3/4 of my CSS without any effect on the appearance of the website. And I was able to remove half of JavaScript without any behavioral changes. The result, in time, it was a dramatic improvement. Definitely something not to be missed. It was the biggest improvement I was able to make. Okay, just a quick recap. 3 takeaways that you can apply to your projects tomorrow. First is to prioritize performance. Treat performance as a feature, because there is no reason that our web applications needs to be slower than the mobile counterparts. We have everything we need. We just need to think about it, test on actual devices, think in terms of actual devices of our users. And if your project manager tells you that you have no time for front-end optimization, just grab the statistics that are all over the internet and show it to them that it translates to revenue for the business. Second thing, look for easy wins. Not everything I have shown today is a hard thing to do. Preload for fonts is actually 10 minutes work. Asynchronous scripts might be also very easy in a lot of projects. So really, there is no reason not to have it, and the result in terms of performance might be really worth it. And third, the most important thing is to ship less code. Do we really need to have jQuery by default in a starter in every project if everything what we need can be achieved in 10 lines of native DOM manipulation? I don't think so. We should always remember about it. We should always prove to ourselves that there is more benefit in the thing we are adding than it actually costs us. If you need a full recap, the slides are already available at slides.com/adambar/mobile-web-perf. And I'm open for questions. Thank you.
Hi, thank you for presentation. It's very important topic, and yeah, I'm very glad that you said all of that. I want to talk about measuring. How do you measure these paints, first meaningful paint? What is your favorite tool, or how do you recommend to measure it?
Actually, I was relying on what Chrome DevTools gave me. They have a pretty good way of calculating it. It's some kind of heuristic, probably, especially the first meaningful paint, because they are just assuming something. But it works. It works. It is really nice. They have on the performance tab there is an option to turn on screenshots on the timeline, so you can then analyze the trace recorded, and you can see that the timing that they propose when the first paint happened, when the first meaningful paint happened, is actually what our users experience. So this is probably the best tool I was working with. Everything really is in there. And it's might be a bit overwhelming on start because it's really heavy in all the goodies around, but these metrics are there. There is also a talk from the talk I've mentioned about performance metrics from Google I/O from this year. It is available on YouTube, so I recommend you to watch it. And they are talking about different metrics that might be gathered from JavaScript right now using the new timing APIs available in not only Chrome, I believe. So there might make sense to calculate time for interactive or time when the user is actually able to do something with the website using these JavaScript APIs. And they have whole science behind it, so I recommend it.
Okay. Do you use some online tool like metric service to measure, to gather those things from production?
Not on the scale of this website, but yeah, I think it might make sense. I believe there are a lot of APMs, if I remember correctly, which allow you to that. I believe Reagan does that right now, and not only them probably. So there is a tooling for that for sure.
Thanks.
So with async and defer tags, so how this is similar to what Webpack is doing with accelerating parsing with those optimizations, or is it something completely different?
I'm not sure what Webpack is doing, so I'm not sure I can respond.
So one of optimization, if I remember correctly, is it just makes the app just parse all the code as string, I think, and this simplifies or accelerates parsing. And I was wondering if this is something maybe similar, or if I should stop doing that and start doing async.
Well, these are probably not. These are complementary, probably, I would say, because async and defer more define when these resources are delivered to the browser. So not when they are actually. Well, defer actually tells about the execution, right? But async tells more about when the browser should start asking should care about that content. So I believe this is something that both might work in the same time, but I'm not sure. I would need to look what actually Webpack is doing, so I'm not sure.
Gotcha. We can talk about this offline.
Yeah.
Thanks.
Let's start.